Hello everyone. Luckily is here once again, like every week. So first thing first, I tinkered a little bit with OBS. Let's see if this stream will have a better output than the last few ones, given I've been quite annoyed about things. We will see during the stream. I don't wanna focus on that too much. And I actually want to move on to my notes right away. But I'm not sure you're saying it correctly. Okay, maybe my tinkering broke something. Ah, that's right. I don't know. Oh, maybe I got it. Maybe. Or maybe not. I don't know, but now we are seeing the correct thing, but even if I move, it doesn't seem really effective. Let me change some of the settings as I do things, I guess. What if I apply this? Nope. So you see my mouse, but when I scroll, when I move around, let me see if I type something. It's as if the interactions are not shown. Maybe it's just that. Let me see here. Yeah, it's just dropping, it seems. So, and that's even odder. Literally, Joplin, no. There is something odd in the configuration. Oh. Okay, let's try to fix this. And let me do this. And let me try to fix this somehow. So I changed everything back. Not really everything, just most things. What's going on? The stream is healthy, and that's great. But if I... No, now it seems to be alright. Let's try this. Yeah. Give it a moment. There is a delay for some kind of reason. Even on my side. Even though in theory I removed it. I don't get it. Oh, come on. I have no idea. But now it seems to work. So we're good. I mean, just a few minutes tinkering. Once again, maybe I had to recreate the scenes. I'm not sure. But anyways, here we are. I wanted to move on directly to the notes because we have a bit of a recap from last Thursday where I, technically speaking, I completed my previous section of work that was porting everything from the old provider, the Telmate provider for Terraform, for Proxmox. Maybe it's the opposite, for Proxmox, for Terraform. And I moved to BPG, not RPG, definitely different things, to BPG that is present for both Terraform and OpenTofu. Given my philosophies, I moved to OpenTofu and I've been successful importing everything and more, actually, because now the situation is more florid than it used to be on Telmate. Which means now we need to move forward from a few weeks ago, let's say. Yeah, definitely a few weeks ago, 4 weeks ago, I think. Basically, I dedicated February to this porting of everything. And the solution, or better, the objective is to complete this section dedicated to the building of a resilient configuration that can be replicated using OpenTofu and Proxmox. And then there will be a little bit of documentation that needs to be added. That is because a couple of things are missing. So for example, if you go on Codeberg on the Terraform definitions, first of all, there were some updates that weren't added to that. Moreover, there is the fact that even with everything correct, with the latest updates, there are some missing things. One of them is the vars.tf that is not present. Otherwise, I would share the API key to my cluster, to my Proxmox node host, and I don't want to share that. But at the same time, it makes sense to at least give a template and a couple of words about the needs to use those things that I have in place, that I know and I have in the various notes, but are not present on Codeberg, on the repo for Terraform. And when I do that, I will maybe do the same also for the future OpenTofu repo. Done that, what is needed? Well, there are 3 things that I need to focus on. Let me actually resize something just quickly. 3 things, and they are present in here. One that will be done completely offline, and that is the actual network configuration of the virtual router and everything downstream from it. That is definitely something I will be doing offline, as there are too many, just far too many information that I would put online that would probably reveal where I live and all kinds of things. So that's definitely something I don't plan to do online. Another thing instead is the creation of an Ansible playbook for the basic configuration of the OpenWRT VM itself. Therefore, what I've been doing during the last stream as well, the final configuration I've done after the VM was correctly deployed from OpenTofu, via OpenTofu. And what I actually plan to work on during this stream, at least investigating some of it, is the modularity that I found out on the Terraform documentation, that I'm fairly sure is available also on OpenTofu. Therefore, I wanted to search about that, learn a little bit about that, and maybe try to implement it, and let's see what happens. As far as I understood, it could be exactly what I need, or maybe not, I'm not sure. Anyways, when these 3 steps are done, everything is ready, in my opinion, to move on to the next actual step, that is the start of the cluster, the start of the configuration of my home lab, of my self-hosted cluster inside the house that is completely under my control. Where I can actually start to deploy services. Now I still have some services deployed, many of which are simply running on some different computers, which will then probably be included in the cluster eventually. I don't know. I still have to decide if I actually plan to put Proxmox on all my virtual on all my physical nodes. It was an idea was playing with a few weeks ago, and then things derailed in a different direction between OpenTofu and the stream not working as I want it to work. Anyway, so far so good. It has been over 15 minutes with the stream healthy, completely great, excellent actually. I'm also recording locally, so last week we had a very bad situation with the stream where the stream stopped by itself, as far as I understood. I didn't see any action from myself that would lead to the stream stopping, but you never know. Anyways, that stream was recorded without any issues, so I may need to upload it. First I want to review it, and I didn't have time to do that as I was focused on other things. So let's get into it. First of all, new note, day 19. Modularity in OpenTofu. Yeah, I don't plan on writing there, but in here. Great. And as usual, this goes here. In here we have OpenTofu documentation, and this will be useful. Proxmox documentation, I don't need it. Telnet documentation, I don't need it, I would say, anymore. And this is BPG, but the GitHub page is not needed. This is just OpenTofu. And this is Terraform actually. And maybe in here I can search even here for modularity. Something like that. Documentation. Wow. Modularity is not giving much to me. Modularized configuration. Maybe this. But I'm not wanting a migration. Let's try to search directly on OpenTofu. This is the registry. And I want a documentation instead. Providers module. This is the registry. Let's reopen this. That is not the registry. Docs. Getting started. The OpenTofu language, the command line, and internals. Modules. Modules. Okay, is this what I want? Modules are containers for multiple resources that are used together. A module consists of a collection of .tf, .tofu, .tf.json, and or .tofu.json files that are kept together in a directory, but still in a directory. Modules are the main way to package and reuse resource configuration with OpenTofu. That is what I wanted, but I don't know if it is exactly what I understood. The root module. Every OpenTofu configuration has at least one module, so far so good, known as its root module, which consists of the resources defined in the .tf or .tofu files in the main working directory. Main working directory. Okay. Child modules. An OpenTofu module usually the root module of a configuration can call other modules to include their resources into the configuration. A module that has been called by another module is often referred to as a child module. So far so good. Child modules can be called multiple times within the same configuration. And multiple configuration can use the same child module. And that is what I want, probably. But I'm not sure how. In addition to modules from the local file system, OpenTofu can load modules from a public or private registry. This makes it possible to publish modules for others to use, and to use modules that others have published. I don't plan on publishing mine currently, but maybe in the future. And I definitely have no plans on using someone else's modules. So I will skip this part. Using modules. Module blocks, documents, the syntax for calling a child module from a parent module, including meta arguments like for each. Module sources documents what kinds of paths, addresses, and URIs can be used in the source argument of a module block. The meta argument section documents special arguments that can be used with every module, including providers, depends on, count, and for each. And I don't plan on developing, so module development is not for me. Module blocks and module sources. I need to better understand the difference. So, the syntax for calling a child module from a parent module, the kinds of paths, address, and URIs. What kind of paths, addresses, and URIs can be used in the source arguments of a module block. Okay. Creating module sources, and module blocks. I think it's better if I search a little bit more first before trying anything. A module is a container for multiple resources that are used together. Every OpenTofu configuration has at least one module, known as its root module, which consists of the resources defined in the .tf and .tofu files in the main working directory. That means I need a directory hierarchy that is not just, let's say, a root folder, but there will be child folders dedicated to different purposes. That is my point. So, for example, I may want to create templates, but that does not mean that I want to recreate the whole infrastructure. I may just want to update the templates. So I think that maybe I can have a subfolder dedicated to the templates, a subfolder dedicated to the router, a subfolder dedicated to the Fedora Core OS virtual machines, and I go with a plural there for the specific reason that I need multiple VMs to have a cluster, especially a Kubernetes cluster. At first I may start with 5 VMs that are all the same, but then there will be some different configurations for certain of them. We will see. That's the idea a little bit as far as I understood. Let's see if what I'm talking about is actually true. A module can call other modules, which lets you include the child module's resources into the configuration in a concise way. Modules can be called multiple times, either within the same configuration or in separate configurations, allowing resources configurations to be packaged and reused. And that's exactly what I care about. This page describes how to call one module from another. For more information about creating reusable child modules, see module development. Why module development? Let's go back to module. For information about developing reusable modules. Maybe I actually need the module development. Oh yeah, it goes here. Okay, no worries. This and this first. Calling a child module. To call a module means to include the content of that module into the configuration with specific values for its input variables. Modules are called from within other modules using module blocks. So module servers source .app ./app cluster servers 5. A module that includes a module block like this is the calling module of the child module. The label immediately after the module keyword is a local name, which the calling module can use to refer to the instance of the module. Within the block body, between the graph brackets, curly brackets, Jesus. The open curly bracket and the closed curly bracket are the arguments for the module. Module calls use the following kinds of arguments. The source argument is mandatory for all modules. The version argument is recommended for modules from a registry, and indeed it's not there, but it's okay. Most other arguments require, wait a minute, I lost myself. Most other arguments correspond to input variables. Defined by the module. The server's argument in the example above is one of these input variables. Okay. Now we need to look better into this as well. OpenTofu defines a few other meta arguments that can be used with all modules, including for each and depends on. So I guess we could say that the cloning of the templates for the creation of the actual VM depend on the creation of the templates themselves. Without the templates, there can not be the creation, or better, the cloning of a template. But let's move forward to understand better. All modules require a source argument, which is a meta argument defined by OpenTofu. Its value is either the path to a local directory containing the module's configuration files, or a remote module source that OpenTofu should download and use. Once again, not my case. For more information on possible values for this argument, see module sources. I will go there, no worries. The same source address can be specified in multiple modules, multiple module blocks, to create multiple copies of the resources defined within, possibly with different variable values. And that's where things start to get interesting, because that is exactly what I plan to do for the creation of the 5 Fedora CoreOS VMs. If 5 will be fitting inside my Proxmox host, that is, we will see. I think so, but I'm not sure. After adding, removing, or modifying module blocks, you must rerun tofu init to allow OpenTofu the opportunity to adjust the installed modules. By default, this command will not upgrade an already installed module. Use the -upgrade option instead to upgrade to the newest available version. So I will need upgrade if I change a module. If I add a module, it's just tofu init once again. This is good stuff. Version. I'm not planning on doing that currently. Maybe in the future I will have a local registry if I need it. I don't think I will for the time being. But anyways, along with source and version, OpenTofu defines a few more optional meta arguments that have special meaning across all modules, described in more details in the following pages. Count. Create multiple instances of a module from a single module block. Sorry. I hope I'm not getting a cold because I don't like that, but I'm a bit closed up. For each, creates multiple instances of a module from a single module block, which is very similar. Maybe one allows the change of some details, I guess, not sure. Providers, pass provider configuration to a child module. See the providers page for details. If not specified, the child module inherits all of the default unaliased provider configuration from the calling module. This is not clear. This is not clear. Okay, passing a provider is clear. Details in here is clear. Inherits all the default unaliased, so without an alias, provider configuration from the calling module. This calling module thing is the thing that I am struggling with, because as far as I understood, we didn't talk about calling modules so far. Is this the calling module? Sì. Yeah. Yes. I will need to see some examples. Depends on, create explicit dependencies between the entire module and the listed targets. Okay, maybe it's not exactly what I was thinking about. And lifecycle allows lifecycle customization for modules, as described in the module lifecycle below. And that's here. Module lifecycle. A lifecycle block inside a module block allows some customization of OpenTofu's behavior relating to the overall module core, rather than to individual resources inside the module. Okay. Module call lifecycle currently support only a single argument enabled, which controls whether the module call will be used by OpenTofu. When set to false, the content of the module is excluded from the configuration, as if the call didn't exist. When set to true, the default, the module operates normally. Okay, this is interesting. It can fit the idea of just upgrading, or better, recreating the templates without recreating the actual clones, because I can put a life cycle with enabled false, maybe, and the cloned VMs will not be recreated. Not sure. Accessing module output values. The resources defined in a module are encapsulated, so the calling module cannot access their attributes directly. However, the child module can declare output values to selectively export certain values to be accessed by the calling module. For example, if app cluster module referenced in the example above exported an output value named instances underscore IDs, then the calling module can reference that result using the expression module.servers.instances underscore IDs, as seen here. Okay, this can be useful. I don't know if I actually need it in my case, but it's interesting for sure. For more information, yeah, whatever. Transferring resource state into modules. Moving resource blocks from one module into several child modules causes OpenTofu to see the new location as an entirely different resource. As a result, OpenTofu plans to destroy all resource instances at the old address and create new instances at the new address. Okay, so basically when I start to recreate everything will be destroyed anyways, whether I want it or not. To preserve existing objects, you can use refactoring blocks to record the old and new addresses for each resource instance. Not something I care about, to be honest. Let's see if this one needs to be restarted. Replacing resource within a module. Resources. You may have an object that needs to be replaced with a new object for a reason that isn't automatically visible to OpenTofu, such as if a particular virtual machine is running on degraded underlying hardware. In this case, you can use the -replace planning option to force OpenTofu to propose replacing that object. Not too clear about that. Oh, okay, now it is clear. It's in the command actually. Interesting. Truly interesting. Removing a module, the same as any resource, a module can be removed as well by using the removed refactoring block. When you remove the configuration of a module, OpenTofu will destroy all the resources that the removal module was managing. There are cases when the module is wanted to be removed from the configuration, but the resource managed by it should stay untouched. To achieve this, follow these steps. Delete the module from the configuration, add the remove block. Instead, specifying the module address you want to forget in the from attribute. Okay. Specify the lifecycle destroy to false. Wait a minute. Lifecycle add only enabled. Can support a single argument enabled. But it seems it supports also the destroy. Probably they added a destroy, but they didn't update the lifecycle description. Maybe. The source argument in a module block tells OpenTofu where to find the source code for the desired child module. OpenTofu uses this during the module installation step of Tofu init to download the source code to a directory on local disk so that other OpenTofu commands can use it. The module installer supports installation from a number of different source types. In my case, it will be just local path, or maybe some S3 buckets, if I plan to deploy something like that as well later on. Not sure. Each of these is described in the following section. module source addresses use a URL-like syntax, but the extensions to support unambiguous, okay, difficult to pronounce, ambiguous selection of sources and additional features. We recommend using local file paths for closely related modules, used primarily for the purpose of factoring out repeated code elements, and use a native OpenTofu module registry for modules intended to be shared by multiple calling configurations. We support other sources so that you can potentially distribute OpenTofu modules internally with existing infrastructure. Many of the source types will make use of ambient credential, but ambient is in quotes, available when OpenTofu is run, such as from environment variables or credential files in your home directory. I don't like that. But anyways, this is covered in more detail in each of the following sections. We recommend placing each module that is intended to be reusable in the root of its own repository or archive file. But it is also possible to reference modules from subdirectories. Local path. Local path references allow for factoring out portions of a configuration within a single open source repository. Single source repository. Open source is a Freudian slip, I guess. Module console, and console is a label, it is a local label. Source dot slash console. A local path must begin with either dot slash or dot slash. Okay, so they are all relative paths. It doesn't seem it allows for absolute path, to indicate that a local path is intended to distinguish from a module registry address. The local paths are special in that they are not installed in the same sense that other sources are. The files are already present on local disk, possibly as a result of installing a parent module, and so can just be used directly. The source code is automatically updated if the parent module is upgraded. Note that OpenTofu does not consider an absolute file system path, starting with a slash, drive letter, or similar, to be a local path. Instead, OpenTofu will treat that in a similar way to a remote module and copy it into the local module cache. An absolute path is a package in the sense described in modules in package subdirectories. We don't recommend using absolute path, absolute file system path, to refer to modules, because it will tend to couple your configuration to the file system layout of a particular computer. I mean, I guess, yeah, it's better to use relative path, I guess. Module registry, I don't care. GitHub, I don't care. Bitbucket, I don't care. Generic Git repository, I don't care. selecting a revision, with the hash, I don't care, shallow clone, larger repositories, no, nope, nope, SCP-like address syntax, nope, generic Mercurial repository, I don't even use Mercurial, I think I've heard Mercurial twice, and I think it's something like Git, or something like GitHub, maybe. Mercurial. Wow. Wow. I didn't expect this at all. IT. Is a free distributed source control management tool. It efficiently handles projects of any size and offer an easy and intuitive interface. So it is similar to Git. Yeah, I have a friend that used to use this, I think. But anyways, it's beyond the scope, I will not use it. Selecting a revision in case of Mercurial, I guess, but OCI distribution repository, not planning on doing that. And in case I plan in the future on doing that, there is the documentation. Same for HTTP URLs. S3 buckets, Google Cloud Storage bucket, moduling package, subdirectories. Okay, this was referenced and it is about the absolute path. So this can be useful. When the source of a module is a version control repository or archive file, generically a package, the module itself may be in a subdirectory relative to the root of the package. Okay. A special / syntax is interpreted by OpenTofu to indicate that the remaining path after that point is a subdirectory within the package. For example, HashiCorp console AWS / modules console cluster. Okay. Okay. Arguments support for variable and local evaluation. I mean, I still need to start, so okay, let's try to understand if I can actually use this. It has been almost an hour and I have yet to write anything in my notes. Because even though I have read the documentation for at least half an hour, if not a little bit more, it doesn't mean anything for myself. A module is a container of multiple resources that are used together. You can use modules to create lightweight abstractions. And that's why I need some practice, because it's an abstract thing. this modularity, so that you can describe your infrastructure in terms of its architecture rather than directly in terms of physical objects. The .tf and or .tofu files in your working directory when you run tofu plan or tofu apply together form the root module working directory. Okay. That module may call other modules and connect them together by passing out values from one to input values of another. To learn how to use modules, see the module configuration section. Yeah, thank you. This section is about creating reusable modules that other configuration can include using module blocks. Yeah, I've read that already and I want to start creating something. If I don't create modules and such things, how can I actually help out understand this stuff? Reusable modules are defined using all of the same configuration language concepts we use in root modules. Most commonly, modules use input variables to accept values from the calling module, output variables to return results to the calling module, which it can then use to populate arguments elsewhere, and resources to define one or more infrastructure objects that the module will manage. And that's exactly what I want to do. And I'm not sure if I can actually do it as I want it. To define a module, create a new directory for it and place one or more .tf files inside, just as you would do for a root module. OpenTofu can load modules either from local relative paths or from remote repositories. Yeah. If a module will be reused by lots of configuration, you may wish to place it in its own version control repository. Okay. Modules can also call other modules using a module block, but we recommend keeping the module tree relatively flat and using module composition as an alternative to deeply nested tree of modules. Module composition, okay. Because this makes the individual module easier to reuse in different combinations. When to write a module? In principle, any configuration, or better, any combination of resources and other constructs can be factored out into a module. But overusing modules can make your overall OpenTofu configuration harder to understand and maintain. So we recommend moderation. That seems fair. I don't know if modularity is exactly something I want to do. For the time being, I'm not understanding. I need some actual examples or practice. Anyways, A good module should raise the level of abstraction by describing a new concept in your architecture that is constructed from resource types offered by providers. For example, AWS instance and AWS ELB are both resource types belonging to the AWS provider. You might use a module to represent the higher level concept, HashiCorp console cluster running in AWS, which happens to be constructed from these and other AWS provider resources. We do not recommend writing modules that are just thin wrappers around single other resource types. If you have trouble finding a name for your module that isn't the same as the main resource type inside it, that may be a sign that your module is not creating any new abstraction, and so the module is adding unnecessary complexity. Just use the resource type directly in the calling module instead. Okay, I did manage previously to describe a different abstraction. So the different abstraction was the templates recreation section, let's say, or better, module maybe, if it is correctly as I have understood. That is one module dedicated to the creation and eventually recreation and so on and so forth of the templates. Same thing for the creation of the cluster itself. 5 currently VMs of the Fedora CoreOS basic configuration I have, but it is a basic configuration that is currently available and may not be available in the future. What I mean is, no, I didn't speak properly. I was thinking of something and I said it wrong. What I mean to say is that currently the configuration of the basic virtual machine is kind of hard-coded. So for example, it will be 192, 168, 100. The static IPv4 configuration for that VM. And that is correct. No issues there. At the same time, if I create 5, I cannot create 5 with the same IP address. So that hard-coded configuration will need to become a different kind of configuration, which can be easily managed by having different snippets. And currently I have a resource for the snippet, and I can loop in that resource, changing the file, having 5 files, one each for VM, because that's the only thing that changes, if I recall correctly. 5 snippets, VM 1, 2, 3, 4, 5. Okay, and this is another abstraction layer. So it seems that I can define these abstractions. Router, maybe this is the easy one, and I can just use the actual resource with the provider in the folder that is one level up from it, I don't know if I can do it without modularity though. So, anyways, it seems that's a possibility. Let me write a couple of things because otherwise I will not really remember. The abstraction layers. The layers I can envision are, and maybe now this is the correct one way. What are they? Templates. A module that will be dedicated to the creation and recreation of the sorry, templates in the Proxmox hosts, currently at least. Yeah, this is correct. Templates. Fedora core OS. A module that will be dedicated to the creation and recreation of the multiple instances of the FCOS basic configuration. And router with a big question mark. Maybe a module that will be dedicated, but that is, well, look at this, if you have trouble finding a name for your module that isn't the same as the main resource type inside it, look at this. It is exactly this situation. Okay, maybe a module that will be dedicated to the creation and recreation of the router VM. This one seems to be the example that should not be implemented. And I can quote the documentation. Quoting OpenTofu documentation, and I will also add a note. Okay. When, wow, the factory module resources. Yeah, it's not my case, I don't have module resources. Therefore, it would seem that two modules are indeed sensible. One definitely isn't, as far as understood. I noticed that doing that always results in an extra space. Okay, module composition. In a simple OpenTofu configuration with only one root module, we create a flat set of resources and use OpenTofu expression syntax to describe the relationship between these resources. Resource AWS VPC, example, Cedar block, and resource AWS subnet, example, and we get the VPC ID using AWS VPC.example.ed, availability zone, and Cedar block, Cedar subnet. It is the AWS VPC example Cedar block 4.1. Interesting. What does it mean? What does it mean? When we introduce module blocks, our configuration becomes hierarchical rather than flat. Each module contains its own set of resources and possibly its own child modules, which can potentially create a deep, complex tree of resource configuration. However, in most cases, we strongly recommend keeping the module tree flat, with only one level of child modules. That seems to be what I want to do. And use a technique similar to the above of using expressions to describe the relationship between the modules. Okay, source modules AWS network, Cedar, okay, console cluster, modules AWS class, console cluster, VPC module.network.vpcid, module.network.subnet IDs. We call this flat style of module usage module composition because it makes multiple composable building blocks within block modules and assemble them together to produce a larger system. Instead of a module embedding its dependencies, creating and managing its own copy, the modules receive its dependencies from the root module, which can therefore connect the same modules in different ways to produce different results. I like the theory in theory, but I'm not certain I understood. Why is that? Well, we have different things and no indication about this is the root, this is the child, this is the interaction that is being created. But anyways, The rest of this page discusses some more specific composition patterns that may be useful when describing larger systems with OpenTofu. Okay, in the example above, we saw a console cluster module that presumably describes a cluster of HashiCorp console servers running in AWS VPC network. And thus, it requires as arguments the identities of both the VPC itself and of the subnets within the VPC. Okay. An alternative design would be to have the console cluster module describe its own network resources. But if we did that, then it would be hard for the console cluster to coexist with other infrastructure in the same network. And so, where possible, we prefer to keep modules relatively small and pass in their dependencies. The dependency inversion approach also improves flexibility for future refactoring, because the console cluster module doesn't know or care how those identifiers are obtained by the calling module. A future refactor may separate the network creation into its own configuration, and thus we may pass those values into the module from data sources instead. Conditional creation of objects. In situations where the same module is used across multiple environments, it's common to see that some necessary objects already exist in some environments, but needs to be created in other environments. For example, this can arise in development environment scenarios. For cost reasons, certain infrastructure may be shared across multiple development environments, while in production the infrastructure is unique and managed directly by the production configuration. Rather than trying to write a module that itself tries to detect whether something exists and create it, if not, we recommend applying the dependency inversion approach, making the module accept the object it needs as an argument via an input variable. For example, consider a situation where an OpenTofu module deploys compute instances based on a disk image, and in some environments there is a specialized disk image available, while other environments share a common base disk image. Rather than having the module itself handle both of the scenarios, we can instead declare an input variable for an object representing the disk image using AWS EC2. As an example, we might declare a common subtype of the AWS AMI resource type, and data source schemas. Declare an object using only the subset of attributes the module needs. OpenTofu will allow any object that has at least these attributes, ID and architecture. The color of this module can now itself directly represent whether this is an EMI to be created in line or an EMI to be retrieved from somewhere else, from elsewhere. In situation where the EMI will be directly managed. This is consistent with OpenTofu's declarative style. Rather than creating modules with complex conditional branches, we directly describe what should already exist and what we want OpenTofu to manage itself. By following this pattern, we can be explicit about in which situation we expect the EMI to already be present and which we don't. A future reader of the configuration can then directly understand what it is intended to do, without first needing to inspect the state of the remote system. In the above example, the object to be created or read is simple enough to be given in line as a single resource, but we can also compose together multiple modules as described elsewhere on this page. In situations where the dependencies themselves are complicated enough to benefit from abstractions. This is tough, to be honest. This is tough. Assumption guarantees. Every module has implicit assumptions and guarantees that define what data it expects and what data it produces for consumers. Assumptions guarantee. Precondition, condition, error message. Multi-cloud abstraction. Data-only modules. Providers within modules. Publishing module, refactoring standard module structure. This is important too. Okay. some example, because I'm losing myself by only looking at the documentation and reading the documentation. I need a working example, and not just a couple of snippets. I need a working example, and that means searching for a working example. OpenTofu module usage example. I hope there is something. Oh wait, right. Standard module structure. Okay, let's see this thing. We recommended the module following the standard structure is shown below. While the root module is the only required element, we recommend the structure below as minimum. Main.tf, variables.tf, outputs.tf. Interesting. I don't know what to put on outputs.tf. And not really even in variables.tf. But anyways, a complete example of a module following the standard structure is shown below. This example includes all optional elements and is therefore the most complete a module can become. Readme, main.tf, variable.tf, outputs.tf, whatever. Modules, nested A, readme, variables, main, outputs, nested B, same kind of thing. Examples, example A, main.tf, example B, same thing. Okay. A root module. These are recommended file names for a minimal module, even if they are empty. Main.tf should be the primary entry point. For a simple module, this may be where all the resources are created. For complex module, resources creation may be split into multiple files, but any nested module calls should be in the main file. Wait. For a complex module, resource creation may be split into multiple files, but any nested module calls should be in the main file. Variables.tf and outputs.tf should contain the declaration for variables and outputs respectively. So far so good for the variables and outputs. Nested module calls. What the fuck? Nested module should exist under the module subdirectory. That's okay. Any nested module should with a readme is considered usable by an external user. Okay. If a readme doesn't exist, it is considered for internal use only. Nice. These are purely advisory. OpenTofu will not actively deny usage of internal modules, blah 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 blah, whatever. Okay, if the root module includes calls to nested modules, they should use a relative path, like whatever. So at OpenTofu we consider them to be part of the same repository or package rather than downloading them again separately. Yeah, we read that. Containing multiple nested modules, they should ideally be composable by the caller rather than calling directly to each other and creating a deeply nested tree of modules. Example of using the module should exist under the examples subdirectory at the root of the repository. Each example may have a readme to explain the goal and usage, because example will often be copied into other repositories for customization. Any module blocks should have their source set to the address an external caller would use, not a relative path. Not clear, but it's okay. An actual example. Oh, module guide. Yeah, I wanted to create something like this, by the way, of my own plans, but it's not exactly easy. Depends on. Okay. Tell me I'm already doing it somewhat. So this is module USB error. Okay, let's read a little bit. Structure decompose language. Contain object to configure the resources to use OpenTofu module, import them. File, specify the source. For example, ABC company has payroll software and wants to implement it in different countries and regions. Each country will have its instance of software deployed on the AWS cloud. Okay. Not sure what happened, but it's okay. Using the same architecture. It has a single EC2 using the custom AMI to host the application server. DynamoDB, NoSQL DB will be used to store the employee and payroll data. The S3 bucket stores the pay stubs, tax forms, and other documents. So we need to create a reusable OpenTofu module and use it to deploy the same stack of resources in different regions. For example, this is similar to what I want to do. I don't have different regions. I have different resources. Create a new directory for the module codes. This is where the place to store all our reusable modules. So this we have the reusable block for all the required services like EC2, S3 and DynamoDB. Okay, so OpenTofu projects module payroll app. Okay. App server.tf, dynamo table.tf, s3 bucket.tf, variable.tf. Okay. For the structure of a reusable OpenTofu module, defining compute storage and database resources. WS instance configuration app server.tf, this one, var.mei. Okay, so I would need to have a variable that is an mei. That is app region, app server with the name. And depends on this stuff, payroll DB and payroll data. Okay. Bucket configuration, WS S3 bucket, one bucket. And this is payroll data. This DynamoDB, payroll DB. This. Okay. Variables, the three details. I don't know the bucket. Okay, yeah, bucket somewhere in here. Sorry, in here. Var app region, var bucket. Okay. Deploy the application stack in the US East 1 region using the following structure. After creating another directory, US payroll app, and inside the directory create a main.tf file. So OpenTofu project US payroll app, main.tf provider.tf, main.tf, modules payroll app. So it's backwards in a way to what I was thinking originally, at least. It looks almost like that provider is a module and it is then sent to I'm not sure, but definitely there is oh, come on, how do I describe it? But basically, so nested A could be, for example, the folder where Fedora CoreOS no, let's go for templates. Nested A is the creation of the templates. So the current creation of template for Fedora CoreOS and for OpenWRT are moved as a recreated as a module. I guess I need to change some stuff, maybe, for sure, are put in a nested A templates module. Then there will be a specific folder, we say US payroll app, yeah, specific folder named templates creation, I guess, in which there is a main.tf and a provider.tf, maybe, or just main.tf, because the provider can be a module, as mentioned there in the documentation of OpenTofu. There was something provided with the modules. Oh yeah, I already had it in here. Okay. Even though I didn't see, but anyways, what happens is that I create a folder, templates, that recalls the module with the definition of the templates in detail, which is there, with specific variables, basically. And let me see. And then in here, so these are the variables: upper region, bucket, and MEI. Source is the module, upper region, and MEI. That is type string, but there is no default because we pass it to it. So in my case, what would it be? It could be in the actual image. The actual image of the OS, Fedora Core OS, and eventually OpenWRT. That can be the URL directly to there, or the local path that I pass it on, so that I can change it and it can be recreated. I don't remember one thing. That is, if I try to recreate, if it automatically deletes and recreates, or if it tries to do something else. Okay, it seems that I have the idea kind of clear. Then I have another nested that is the definition of Fedora Core OS, basic configuration, with the snippet, in this case, as a variable. And I pass it in there. Instead, the router is the router, and there is nothing to it, I guess. I can have a dedicated folder, maybe. Okay. Best practices for using modules. Okay. Let me try to search something. OpenTofu modules usage example. OpenTofu provider as module. Maybe. Oh yeah, the for each and whatever. I didn't look into it, but it's not. Get started and examples. Not necessarily what I search for, but module, whatever, variable. Provider. Registry. Yeah, this is just a general stuff. I don't need that. What is this? This looks like a definition for cube. Not what I'm looking for. But anyways, I kind of understood something. Let me see. What is it? A bit of a theoretical stream, I guess. Studying things I don't know. Feasibility. Check. No, it's not checking. It's kind of quoting, but it's more like taking the structure presented in the OpenTofu documentation. I got the following. I understood the following a little better. This is exactly as found in the documentation. Better like this. In these it's not exactly the same, but in the structure above nested A. Wait. Thank you. Would include the definitions for the creations of the templates, FCOS and OpenWRT. In the complete modular level a folder named templates include a main dot tf, wait a minute, dot tf, that references nested day. Sorry, but I'm lazy. Nested day. And maybe provider.tf. Unless can use it as a module. That's a B in this case. Good definition for the creations are the creations of FCOS basic VMs. In case of yesterday, the variable to change would be the reference to the image. FCOS and OpenWrt. In the case of nested B, the variable to change would be the reference to the snippet. OpenWrt VM creation doesn't seem to need the how to say the sorry, I seem to need the modularity as much. I will need to think about this one, as it depends if I create a secondary OpenWrt VM as I thought previously. Watch dog and scheduled. This may make the idea of multiple OpenTofu VMs not a need to have. Something like that. Okay, so the theory is here, and maybe next week I can try to implement it and see if it works as intended. I will create a copy of what I have to ensure that I don't destroy anything, since it took a while to create, even though I have everything documented, but I didn't create the repo yet, so everything is only local. So definitely copy everything to have a backup that is untouched, and then move on to try to implement this modularity. That thanks to the example. Actually, let me retrieve it. Thanks to this example, I kind of understood better. So let me write it. To this example, some things better than just reading the documentation. I now need to implement everything, and everything I described, and see the result. Okay, so this is great, actually. I have a clear image in my mind of what I'm trying to do, and now I have the plan set. Next week we can implement things and see if it works as intended. If it works as intended, perfect. If it doesn't, I will need to investigate more, I guess. Anyways, thank you for watching, everybody, and this time it seems that the stream didn't have any issues at all. The status was always excellent, no buffering, no issues. I will of course check it out just to be certain, and check out also the recording and see if there is a better quality locally or a better quality from YouTube or from, I guess, Twitch, and we will see. Thank you everyone for watching. See you next week as usual. Bye.